Welcome to SPMPC classes. Is matter around us pure 2 part 2. Today we are going to learn about the elements, compounds, colloid, true solutions, suspensions. So already I have explained about the elements and compounds. So in this video I am directly going to the true solutions and colloids and suspension. True solution is a homogeneous mixture of two or more substances. In that we are having one is solvent, one is solute. Solute means which is present in less amount. Solvent means which is present in more amount. For example, sugar water or salt water. Sugar, salt, we are taking 1 spoon or 2 spoon in 100 ml water. So sugar and salt which are there in less amount, solute. Water 100 ml which is a solvent. When we combine together solute and solvent, we will get the solution. A solution has a solvent and solute as its components. The component in large amount is the solvent and the component in the lesser amount is the solute. Properties. True solutions are homogeneous mixture. It means salt and sugar when we dissolve in water uniformly distributed. The particles cannot be seen by naked eye. It means we can see by the ultra microscope but we can't see directly with naked eye. The solute particles cannot be separated by filtration method. The solute particles do not settle down and the solution is stable. Yes, okay. If it is settling down, that comes under the sedimentation. But here salt, sugar completely uniformly distributed, dissolved. So they can't settle down. The particles do not scatter. A beam of light passing through it and the path of the light is not visible. Okay, it means when we take true solution, sugar water or salt water, if we take one torch light, if we are allowing that light to passing through it, the path of the light do not visible. Now colloidal solution. Here you should remember that true solutions are nothing but particle size is very small, below 1 nanometer, and colloidal solution particle size is 1 nanometer to 100 nanometers, little bit bigger. Colloidal solution is a heterogeneous mixture, not homogeneous. Okay, heterogeneous mixture of two or more substances. Example, mixture of starch in water, mixture of egg albumin in water, milk, air containing dust and smoke. These are all examples of colloidal solutions. Properties. Colloidal solution is a heterogeneous mixture. The particles cannot be seen by the naked eye. The solute particles cannot be separated by filtration method. The solute particles do not settle down and the solution is stable. The particles scatter the beam of light passing through it and the path of the light is visible in the solution. In true solution, the path of the light is not visible, but in colloidal solution, path of the light is visible clearly. Okay, so this topic is known as Tyndall Effect. The particles scatter a beam of light passing through it and the path of the light is visible. This process nothing but Tyndall Effect. I will show the images. You will get a good clarity about the Tyndall Effect. Scattering of beam of light passing through it. Now we are going to discuss about suspension. Suspension particle sizes approximately more than 100 nanometers. Easily we can see. Suspension is a heterogeneous mixture of two or more substances. Example, solution of sand in water, solution of chalk powder in water, mud water. These are all the examples. Suspension is a heterogeneous mixture. If you see the properties, first one. Second one, the particle can be seen by the naked eye. We can see directly. No need of ultra microscope. The solute particles can be separated by filtration method. If you take the filter paper and if you pour that upon the filter paper, particles it will be easily collected out. And water and small particle size, they can go through the water into the beaker. The solute particles settle down and solution is unstable. Yes, it means particle sizes. If you take mud water, the total mud it will be settled down, sedimentation process, and you can take that water, upper water, easily to the another beaker. The process is known as decantation. Particles scatter a beam of light passing through it and the path of the light is visible in the solution. We can see the path of the light clearly when we are passing a light through the beaker which is having suspension, mud water or salt, solution of sand in water or chalk powder in water. So this is the Tyndall effect. Here you can see first picture. Solute particles can be separated by filtration method. So we have funnel. If you pour water which is there in the beaker, suspension like mud water upon the filter paper, we can get clear water in the beaker. Second image, solute particles settle down and solution is unstable, sedimentation. Okay, after some time, 15 minutes or 30 minutes, we can see that clearly. Now third image is about a Tyndall effect. When a beam of light passed through the suspension which is there in the test tube, we can see the beam of light, scattering of beam of light clearly. So that is known as Tyndall effect. Now we are going to discuss about Tyndall effect. When a beam of light is passed through a colloidal solution, the colloid particles scatter the beam of light and the path of the light become visible in the solution. This effect is called Tyndall effect. We can see such type of effects when we are having a roof which is not concrete roof, that sheet, iron sheets roof. If it is having a hole, the light, if it is passing through the hole, then that light, it looks like a beam of light ray which is coming directly from the sun into the room. Whatever the particles are there in the path of that light, it will be visible clearly. That is known as Tyndall effect. We can see that in forest also. If it is a dense forest, then the light which is coming from the gap between the leaves or branches, the particles which are there in the path of the light, it will be visible clearly. That is a Tyndall effect. We can say that window. Okay, so whatever the light which is coming from the window, that is visible clearly, light rays, and all the dust particles, everything visible clearly. This effect is known as Tyndall effect. Next upcoming topic is separating the components of the mixture. Is matter around us pure, part 3. For that you have to go to the next video. So in that video, which topics we people are going to cover, that I will show you first only. Evaporation, first one, centrifugation, second one, third one, decanalization using the separating funnel. If two miscible liquids are there, how to separate them, and if two immiscible liquids are there, how to separate them, let us see. Sublimation, you know what is meant by sublimation. If solid is directly converted to the gas is known as sublimation. That we will see in the form of experiment. And centrifugation, chromatography technique like capillary action. Distillation and the fractional distillation. Distillation means we can get a distilled liquid which are having a more, we can get distilled water from the distillation method without impurities.